Hello friends, this video on solid states part 3 is brought to you by examfear.com. No more fear from exam. Correct? The next is amorphous. See, amorphous itself, it came from the Greek word amorphous. That is no form. That is the origin of this word. It's a Greek letter, Greek word, amorphous. Right? So it consists of particles of irregular shape. For example, if you see there is no pattern, there is no fixed pattern. These are all constant particles of the haphazard, the irregular shape. Right? So here the arrangement of the constituent particles, again the constituent particles I mean atoms, molecules and ions. This is only short range only. You see, actually there is no order. And even if it's there in some case, it's very short range, maybe 50, 60, 100 pattern, that's all. Correct? So that's all. In this case I am not showing any regular arrangement, but sometimes we do have some arrangement, regular arrangement or regular periodic arrangement, but this pattern is only for short distance. And these structure of these amorphous solids is similar to liquids. They are called solids, but their structure is similar to liquids. Correct? The example can be glass, rubber and plastic. So you see, this is my glass, rubber and plastic. These are a good example of amorphous because they soften over a period of temperature. And thus they can be molded and blown into various shape, because the way if you see the glass is prepared, you melt the glass, you get the glass balls, and then you blow, and then you get this kind of shapes. If you just burn plastic also, you will see that it melts. You take small plastic and try to burn with a candle or this Bunsen burner, you will see that it melts, right? So if you see these amorphous, they melt. We will do one experiment for that. And if you see, as I told, they are liquids. One good example is that if you see this old window panes. So if you see this window panes, old building planes, you will see the width is little different. This is the top, this is the bottom. It is more wide from the bottom. These windows, they are more wide from the bottom. Why? Because this window is made of glass and glass is amorphous, and amorphous behaves like a liquid. Right? So since they are liquid, they have tendency to flow. And they are also called supercooled liquid. That's right. Supercooled liquid. Right? So you see, that's why this glass panes fixed to this windows, the old ones, they are slightly thicker at the bottom, because the glass flows and it becomes more thicker at the bottom. Correct? So the other examples of glass can be the amorphous can be this all glass substance, from starting from the bulb to the test tube, the glass jar, mirror, the bottles, even see the windows glass. If you see this building has all these window glasses, right? All these are my examples of amorphous. Even if you see a very old glass, that will have milky, it will be milky. Why? Because they crystallize. This is again a different property. If you see a very old glass, they crystallize. Very old, I mean maybe 1,000 years old, right? 500 years old. So this glass objects from the ancient civilization, they are little milky because of the crystallization. Because the crystallization happens and they change the color from the normal transparent look to the milky one. Right? And this is called glass transition. When you heat the glass below melting point, some of the amorphous crystallines. Right? So this is called what? Glass transition. I write it here. Correct. I'll repeat the definition once again. So when you heat this glass below melting point, some of the amorphous pattern they crystalline at some temperature. This temperature is different for different kinds of glass or different kinds of amorphous substance, and that's why this glass from the ancient civilization is little milky. Correct. And these amorphous substance, they have short range crystal particles. So at some temperature, these short range also crystallize to long range particles. That's called crystallization. So this is milky because of the long range particles, long range arrangement. This is crystalline, actually, little partial crystalline. So what I'm trying to draw from this conversation of the milky glass or the old civilization milky glass is from amorphous to crystallization also, from amorphous to crystalline, this phase also happens, and this is called glass transition, right, from A to C, amorphous to crystalline, slowly. Okay. So as I have discussed this thing that it heats or it softens over a range of temperature. For example, this one, in the earlier case, in the case of crystalline, when you heat this, then at particular X temperature, it was all melting. But this is not the case. If you heat this, gradually it will melt little bit, and we see from this X to Y temperature range, it will melt. Right? It will melt gradually from X to Y temperature range. Right? They have different temperatures. Also, when you cool it now, you'll see in the case of crystalline, this was the graph we got. There was some temperature, some time where there was no change in temperature. But here, if you see, this is the kind of graph you'll get. Right? So the graph you get is different. The temperature and the time graph. Right? It is different. Also, one thing to be noticed, in case of crystalline, it was anisotropic, but it is isotropic. It is isotropic because it is all haphazard, right? So if you take from this direction, you don't know what will come. It's all haphazard, actually. It's all haphazard. Correct? There is no regular fixed arrangement. So that's why you take from any direction, you say, or you get almost similar physical properties like electrical conductivity or refractive index. Correct? Since there is no long range order, it's all haphazard, all irregular in all direction. So all the physical property, most of the physical property or all the physical property will be same, you take any direction. Correct? One thing I want to clarify is just by looking at the solid, just by appearance. For example, given you see this particular object, just by looking at this, you can't distinguish between crystalline and amorphous. Please note, just by looking at solid, just by the external appearance, it's very, very hard to distinguish between crystalline and amorphous. Right? So they are distinguished. And how they are distinguished? They are distinguished from one another primarily by the degree of order exhibited by the arrangement of the fundamental particles, the constituent particles, that is atoms, molecules, or ions. So it's more by the arrangement, right? For that, you need some high techniques, maybe X-ray diffraction techniques, right, to understand the actual arrangement. Correct? But by some properties, the properties which we have discussed, the cooling property and the heating properties, we can guess, but the actual conclusion will come from the X-ray diffraction technique only. Also, as I discussed, nature favors crystalline. Correct? But when the atoms are not given enough opportunity to rearrange themselves, for example, if the temperature of the liquid drops suddenly and it solidifies, so in that case the motion of the atoms before they rearrange themselves is very restricted because they don't get enough time to rearrange. Correct? So in that case, amorphous materials are also found in nature. I told crystalline is something which nature favors, but the reason why crystalline things happen is because in nature things happen generally in nature. If you see the formation of a coal or diamond, it happens over a period of years, like hundreds of thousands of years. So the substance get enough time to rearrange itself in the crystals. Sometimes I'll talk you to some scenarios where the temperature drops suddenly and the liquid solidifies abruptly. For example, during volcano, right? The lava that comes out. This is a volcano. The volcano, and from this volcano, and this lava, or this lava that comes out. The moment it comes out, the temperature drops suddenly because in the air here the temperature was very very high. It comes out, the atmosphere temperature is very less, and it solidifies, right? It solidifies immediately. So in that case, this amorphous this materials from this all this volcanic eruption, they are generally amorphous, correct? So nature favors crystalline, but in some case like volcanic eruption, you see the natural material being amorphous.
Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.